My capstone is the Solana state channel, and we'll be talking about that. My name is Shinshu, and there's a GitHub link at the bottom if you want to check it out later. Um, so a little bit of background. So kind of want to start with what is the SVM? And according to Joe Caulfield, he's an engineer at ANSA. It's the whole transaction pipeline, and just a little graphic, kind of just showing a high level of like what this transaction processing unit is. And so what ANSA's done in the last year and a half or so is they've kind of decoupled the SVM and created an interface that they can use. And so there's an SVM API that's contained in this Solana SVM crate. And so having decoupled that, there's a couple of things you can do with that. And one of them is a state channel. And what state channel you can do with that is, you can handle the transactions off chain. It will increase performance. So, as you're handling these transactions off chain, you're not clogging up the main networks with some unnecessary transactions. And once you're done with the transactions, then you can settle all these on chain at once. So here's kind of a high level diagram of what I was trying to do. So in Q2, I had created a project, and it was a parking space project. And what it was simply was that the homeowner, they have some extra driveway space that they want to rent out, and it integrated parking sensors to detect, when a car would arrive and leave. And so the process on that I have on top is, just listing the spot and updating the parking status at each different state and stages of the process. And so I thought, well, how can I make this better if I maybe take some of these transactions off chain? And so the way I thought about this is that, with the initial listing and the driver reserving it, that kind of creates like an agreement. And with this, it will just kind of, we can say this opens up the state channel and start the process of handling these transactions and state changes off chain. So for example, when the driver initially arrives at the parking space, triggering the sensor, that will update the parking space status. And also we need to confirm that the driver is actually there, because anything can trigger the sensor. So we want to make sure that the driver is actually at the spot and confirms it. So that'll be another transaction to actually update the state to occupied. And then once the time is up, we're just going to assume that he leaves on time. That will trigger the sensor again, and also trigger a payment to the homeowner. And then that will kind of like end the transaction, and we'll settle this back onto the main chain. So for the state channel implementation, so it actually followed a example that was already out there called PayTube, which the Joe Caulfield, he's an engineer who made that, and just kind of followed his structure. And what I found in his example was that you want to define some kind of struct to keep track of the values that you want to keep track of. So for me, it's like the parking status changes, and also the rental rates, the duration of the rental, and things like that. And so once you kind of gather this information that you want to actually have as instructions and transactions, then there's a instruction and transaction handler where you actually take this info and convert it to a proper like Solana instruction, and then from there you convert it to a transaction and then sanitize transactions. The next part is won't get into too much detail. There's more information on their blog, but essentially there's a transaction batch processor within the SVM API that you want to create an instance. And before you can actually use this, you have to gather a lot of inputs and set up a lot of settings and implement traits, and callback for this to work. And once you have done that, then you can call this load and execute sanitize transactions method, which will process these transactions, and it'll give you an output from that. And so this output object, which is loaded, execute, sanitize transactions output, it'll have information regarding any kind of errors, execution results, and so you can actually use that to, process or filter rather, according to your needs. So basically, you just want, at least in this example, just to process and get the execution results that were successful, not the ones that failed. And once you get all this nice and ready, we can just have a vector of transactions that we submit to the RPC client. And so next, just going to go over a little bit of the code, what I was trying to do. And I'll just kickstart the test here because it takes a little while to get going. So what I tried to do in this test is just so initially you're just going to set the keepers for the homeowner and driver, and then set the rental rate. And actually, within this test, we have a test validator that we're using to kind of like just verify and then process these transactions. And so you can initially set up the accounts that you want and add them to the this test validator. And so from there, we have a driver that wants to rent the space. So it's going to be 35 minutes. And then, so after that happens, we kind of have an agreement between the driver and the homeowner, which is going to open up the state channel. So we just create a new instance of that. And we start building the transactions that we're going to send to the state channel. And so I kind of did this builder method, and I'm just adding these in sequence. So initially, we're going to trigger the sensor, and the driver confirms it. So then it becomes occupied. And once he leaves, the parking space becomes available again, and the transaction happens, and the homeowner receives a payment from the driver. So we have all these transactions queued up, ready to go in this transaction list. And then from there, going to process the transactions. And so that all happens within here. This is what I have so far as my state channel. And let's see. So right now I'm just kind of testing, make sure that the homeowner balances, actually the balances for the driver and homeowner match up as expected after the final transaction. But really at this point, I just wanted to make sure end to end that it's actually going through what I have and processing the transactions and not failing. So later, I'd still want to work on testing some more things and just kind of understanding how this SVM API works a little bit better. And also, the more as I go along and work on this, I think maybe a roll-up is more of what I'm looking for as far as like wanting to keep track of the state changes and more details about those state changes. So, and that's pretty much it. So thank you.